Okay, this is really just to review some of the projectile motion stuff, and it's so one of the first things when we were looking at this question is realizing that Canon spelled incorrectly, I think, anyway. But anyway, it's traveling at 18 meters per second at 43 degrees. So what does that look like? That means it's 18 meters per second, and it means 43 degrees to the horizontal. So if we wanted the horizontal velocity, we would go 18 times cos 43. But we want the vertical at the moment because we're interested in height. So height is the vertical velocity only. So that's going to be 18 times sine 43 because the side is opposite that angle, so we use sine. So if we do that, that equals 12.2 meters per second. Now we should list the information we have. So what's the initial velocity? Well, it's 12.27 meters per second rather. And what is the final velocity when it's actually at that greatest height, when it's at the peak? Well, it's going to be 0. We know that acceleration is minus 9.8 meters per second, and distance is a thing that we're kind of interested in. So when we look at this, we're kind of looking for a formula which doesn't have time in it. So when we look through here, that's got time, and that's got time, and that doesn't. So that's probably a good one. We could have probably used one of the other formula, but we would have had to figure out time at some point. So Vf squared equals Vi squared plus 2AD. Now we just have to substitute in. Now the final velocity is 0, so 0 equals 12.27 squared plus 2 times gravity, which is minus 9.8 times d. Now, because of that minus there, we know this is going to be shifted to the other side. So if we do that and square that first and put it on the other side, that becomes 150.55, and that equals 19.6 d. So the negative disappears because we've shifted one to the other side. So the distance, the 19.6 gets divided into here. And so that means we're going to end up with a calculation of 7.68 meters. Okay, so that's the height. What is the time to the peak? Now, what information do we have here? We've got the initial velocity, which is 12.27 meters per second. Again, we've got gravity of minus 9.8 and meters per second. Meters per second. We do know the final velocity is going to be equal to 0. However, if we just look at the formula here, this, and get rid of all of that, this one here is quite a good one to use. So Vf equals Vi plus At. So final velocity is 0, initial velocity is 12.27 meters per second, minus 9.8 times t. So that becomes 12.27 equals 9.8 t. 12.27 divided by 9.8 equals t, which equals 1.25 seconds. So we've got that time. Now realize that's just the time to the halfway point there. So the total time until it hits the ground, which we're going to be interested in the next part, is what we're interested in. So we have to times the time by 2, because the way we work out the horizontal distance or the range is knowing what the velocity is going horizontally, which is going to be from the earlier part, which is 18.18 times cos of 43. That will give us the horizontal velocity. Now that's 13.16 meters per second. How long was it in the air for when it was going that velocity? Well, it was this whole time, which is that times 2, which is 2.5 seconds. So we now just multiply 2.5 times 13.16, and that should give us the correct answer of 32.9 meters. So that's a total range. Now obviously if that was 2SF, that would be 33 meters. Okay, so let's see. Now this should be question 5. We'll just put that there. And I thought I'd put this here just as another example because of just straight kinematics. So Obviously, the assumption in kinematics is that it's uniform acceleration. There's a constant, constant set rate of acceleration. So for this one, what is the information we know? We know the distance is 200 meters. We know the time is 8.5 seconds. And if it's starting from rest, we know the initial velocity is 0 meters per second. So now if we come up to here and we're looking through this formula, which of the ones can we use? This one has distance and it has initial velocity. We have time, but acceleration is what we want to know. So that's probably a good one to use. Okay, so D equals VIT plus half AT squared. So that means 200 meters. Now the initial velocity is 0, so this is going to end up being 0. So just equals 0 plus half times A times T squared. Now the T is 8.5. Sorry, I'm really at the end there, so I'm just going to rewrite this over here. 200 meters equals half times A times 8.5 squared. So I would square this first, just to make sure I don't make a mistake, and then I would times that by half or divide it in 2. So that will give you 200 meters equals 36.125. This squared equals something like 72, and if I divide it in half because of that, I get 36.125 times by A. So that means I have to divide the 200 by 36.125, and that gives me 5.54 meters per second per second. Now, if that was to 2SF, that would just be 5.5. All right. Okay, final question, which is a bit of a repeat of an earlier one in some respects. We're trying to work out a time, and we've got a snowmobile with a final velocity of 24.5, and it goes from rest. So initial velocity is 0, final velocity is 24.5, and the acceleration is 1.5 meters per second. So we look through the formula, we find the one that's kind of going to work for us is going to be this one here. Okay, VF equals VI plus AT. And that's because we have the final velocity, we have the time, but we basically don't have the time. So that's 24.5 equals 0 plus 1.5 times by t. So that becomes 24.5 equals 1.5 t. 24.5, I should put the units in there, divided by 1.5 equals time. And so it equals 16.3 seconds equals t. And if we go to two significant figures, that's just 16. And that's the last question.